Hi, kids! So we're going to do another two-body problem, except this time our blocks, rather than being attached via string, are just going to be attached via touching. So in this case, we're going to be pushing to the right on this one, and we want to find the contact force between the two, and we want to find the acceleration. Okay? So I'm going to show you, there's a couple different ways you could approach it. Because I am asking you to find the contact force, you will have to draw the forces on each individual box, but I will show you at the end how we could, if it was just the acceleration, how you could solve this really easily by just treating this as one big blob, okay? All right, so let's talk about how do we find, that contact force and the acceleration. So just like we did before, let's use some colors. So we'll have our 5 kilogram block be red, and our 2 kilogram block be blue. All right, so what do we do first, ladies and gentlemen? What do we do? Oh, that's right. We draw a picture. So here's our picture, but that's not going to help us write an equation. So what picture do we have to draw to write it to help us write an equation? That would be the FBD. So let's draw our FBD. So we'll draw it for the 5 kilogram block. All right, so I would have the force of gravity going down, the normal force going up. Okay, I would have this. I'm pushing on this block this way. Now, if you want to label this, because we're saying you push on there, so if you want to write, the force from you here, I guess you can do that, but I'm not going to really write FU on my paper here, so I'm just going to call it the random generic force, the applied force, okay? All right, and then what other forces are acting? Well, this 2 kilogram block is going to push on this 5 kilogram block. That's going to be our contact force. I'll call it FC. And then I'm also going to have a force of friction going this way, okay? Because if this block starts at rest, I should have said that, and it's going to start accelerating, it's going to start moving and accelerating to the right, well then my friction has to oppose that. So a couple things to note. This and this are the same size. Are they always the same size? No, ladies and gentlemen, of course they aren't. You're going to figure that out by drawing your FBD. In this case, they're the only two perpendicular forces, so they have to cancel each other out. So let's write that first. So Fn is going to equal Fg, which is going to be 5 times 9.8, which is going to be 49 newtons. Okay? So, hey, we're getting somewhere. And then let's write our parallel equation. So our parallel equation is going to be, and you'll notice this force has to be bigger than these two added together. That's why I drew this one so big, because if I go this plus this one still has to be bigger than that. So if I write my parallel equation, I get Fa minus, now some people like to write it this way, where they say minus these two forces added together, which is great and wonderful, equals 5 times A, because that's m times A. Or if you'd rather just write it this way, that's totally cool also. Because guess what? It's the same thing. Okay, so either way is fine. So there's our equation for, and actually let's plug in some numbers. So Fa, we said, is 10. The force of friction is going to be mu times the normal force. So mu times Fn. Oh, well, this is 0.1, that's 49, which means this is 4.9. This is going to be Fc, that's what we're looking for, and we don't know A, so I end up with 5.1 minus Fc equals 5 times A. Hey, that's pretty nice. Okay? All right, so now if we do for the 2 kilogram block, okay, so I'm going to draw my FBD. There's my 2 kilogram block. I would have the force of gravity. Of course, it has to be smaller than this force over here because, it's smaller. I would have the normal force. Now, in this case, what force is pushing to the right? Oh, yeah, that's my contact force. And then going against that is going to be the force of friction. Okay, So that's what your FBD should look like. Now, a couple things to note here, okay? This force and this force have to be the same size. Why? Because this is the 5 kilogram block pushing on the 2 kilogram block, and this is the 2 kilogram block pushing back on the 5 kilogram block. For every action, there's an equal and opposite reaction. Now remember, these two are not action-reaction pairs, because this is the table or the ground pushing on the 2 kilogram block, where this is the earth pulling down on the 2 kilogram block. That is not an action-reaction pair, okay? But this and this are action-reaction pairs, okay? And then these three, or these, I'm putting 3 slash marks, but these two forces are going to cancel out. So again, Fn is going to equal 2 times 9.8, which is going to be 19.6 newtons. And then my force of friction acting on this box is going to be 1.96 newtons. How do I do that? Because I did mu Fn, okay? All right. Then I'm going to write my parallel equation. This block has to accelerate to the right. Why? Because this block was also accelerating to the right. So this is going to be Fc minus Ff equals 2 times A. And if I plug my stuff in, I get Fc minus 1.96 equals 2A. And then look, I have 2 equations, 2 unknowns. So let's write them right underneath one another. And that's what I'm going to do. Again, do you have to solve it this way? No, you can solve it however you want. But I just think this way is nice because, hey, look, Fc just went away. So I got to use my handy-dandy calculator here. So 5.1 minus 1.96, 3.14. Hey, that's pi. Equals 7 times A divided by 7. So A equals 0.4 around 5 meters per second squared. Okay? And it is going to be pointing that way. All right, so there's my A. And then to solve for my Fc, I can just take this and plug it into this equation, or take this and plug it into this equation, and I should get the same thing. So let's do that. Let's plug it into there. So times 2 plus 1.96. So I get my contact force to be 2.86 newtons. And it depends. It's either pointing to, it's either this way or it's this way, depending on which force we're talking about. Okay, let me plug it into this one just to check it. So if I say 5 times 0.45, and then I go 5.1 minus that answer, hey, look, I get 2 point. It's a little bit. It's rounding different, but it's you get the same thing. Okay, so that's how you do it that way. Draw your, again, same steps as always. Picture, equations from your picture, and then you solve. Now, I just want to show you how, if you wanted to, you could treat this as one big blob. So if I was treating this as one big blob, now this would just be to find the acceleration. But if I was treating it as one big blob, this is what my FBD would look like. So now I have this 7 kilogram blob here. And then I would have this, the normal force. I would have the force of gravity. And yes, those two forces would cancel. On my 7 kilogram blob, I have my applied force and then my force of friction. Oops. Okay. Now, why am I not putting the contact force? Because that's an internal force. Remember, you only draw the outside forces acting on your object, which are these. Well, then if you write your equations, so in this case, you would get Fn equals 7 times 9.8, which is, that I can't do in my head, 7 times 9.8, 68.6 newtons. And then my parallel equation would be Fa minus Ff equals 7A. So then Fa is 10. Ff is going to be 68.6 times 0.1, which is 6.86 equals this. And if we do the math, let's do the math. 10 minus the answer and divide by 7, and wow, you get the same thing. How amazing. So you could, if you treat it as one object, it's really quick and easy to solve for the acceleration. But then if you wanted to, Like let's say I drew this and then I drew this up here. I could actually then just plug in to this equation once I know my A and then solve for FC. So I hope that makes sense. Bye, kids.